If you are a teacher or a student who wants to construct your own system of equations, an original one, then this video is for you. Let's begin from system of two equations of two unknowns. To begin, you have to write down the solution that you want to come up at the end. For example, you want a solution that gives you x equals 2 and y equals 1. Okay, this is the solution that you want to come up at the end. Now, let's now start constructing our equation. Here, you can select any of the coefficients you want. For the coefficient of your x, you have to write down the actual value of it, which is 2. Then, say for example, coefficient of your y is 3. Operate this one, this is 8. That's minus 3. So 8 minus 3 gives you 5. So make sure that you have the correct result here when you operate the operations on the left side. And then the second equation, for example, you want to put negative 2 times, okay, our x is 2, and say plus, say 5 times 1. And then this is negative 4 plus 5. So the answer is 1. So therefore, the equation that gives you this solution is, we now change our 2 to x and 1 to y. This is now 4x minus 3y equals 5 minus 2x plus 5y equals 1. Now this is now the equation that we constructed. Now next is, let's check if this equation really works, if it really gives us this solution. This is our equation 1 and this equation 2, and what we're going to do is we'll multiply 2 to equation 2, multiply 2 to it, so we now have that's 2 times negative 2, that's negative 4x, 2 times 5y, that's 10y, 2 times 1 is 2. And then our equation number 1, that's 4x minus 3y plus 5, and then we add them together. Here our x is eliminated, and we have 7y equals 7. That gives us y equals 1. Okay, we can now substitute our y equals 1 to any of this equation here. I will select equation 1. So 4x minus 3, our y now is 1, equals 5. And we have 4x, move this is negative 3, and move it here, it becomes positive 3. Cancelled out. So this is equal to 8 divided by 4. Okay, x is equal to 2. So here our solution set is equal to the set where x is 2 and y is 1, which is exactly what we want here. Let's move to system of equations with 3 unknowns. Say for example, again, we'll start from our desired solution. So I want my solution be x equals negative 2, y is 0, and my z is 1. And let's not start constructing here. I want my coefficient of x to be 4 for my first equation, and my x is negative 2 minus 2 times 0 minus 4 times 1. Okay, let's operate this. It's negative 8, it's 0, it's negative 4, gives us negative 12. And then for the second equation, I want it to be negative 3 for the coefficient. X is negative 2, then plus 5 times 0, and then minus 5. Sorry, my z is 1. Let's operate this. This is 6, 0 here, minus 5. That gives me 1. And for the third equation, 5 times negative 2, I wanted 5. And minus 6 times 0, I want this to be 3 times 1. Okay, let's operate this. It's negative 10. That's 0 there, 3. Gives me negative 7. Alright, we have already constructed our three equations. We can now change our the values to x, y, and z. Therefore, the equation is 4x minus 2y minus 4z equals negative 12. Negative 3x plus 5y minus 5z equals 1. And then 5x minus 6y plus 3z equals negative 7. So this is now the resulting equation that we want. Next, we need to find out if this really works and if this really gives us this equation, since we're dealing now with three-dimensional line. Okay, so I will take this as my equation 1, this is equation 2, and equation 3. And I will decide on eliminating my y first. I'll multiply negative 3 to my equation 1, and that gives me, okay, wait first, it gives me negative 12, then plus 6, negative 12x plus 6y, then plus 12z equals 36. And then equation 3, 5x minus, just copy it, okay, 3z, negative 7. And then let's add them. Y is now eliminated, and we have, what is this? Negative 7x. This is 15x, 15z, and this is 29. Okay, let's name this our equation number 4. Now let's take another pair of equations, equation 1 and 2. So let's take equation 1 and equation 2 to eliminate our y. So we need to eliminate the same variable to reduce it into two variables x, y, x, z. We multiply 5 to equation 1 and multiply 2 to equation 2. So we then have 5 times 4, that's 20x. 5 times negative 2, that's negative 10y. 5 times negative 4, that's negative 20z is equal to negative 60. And for equation number 2, that's negative 6x plus 10y, then minus 10z equals 2. Add them together, our y now is eliminated. We have 14x minus 30z equals negative 58. Okay, we can take this our equation number 5. It's now reduced to equations of two unknowns here. We eliminate x, then we can solve our z. Now I will put my equation 4 and 5 together. 4 and 5 to eliminate x. Oh, I have now equation 4, which is negative 7x plus 15z plus 29. And my equation 5 is 14x minus 30z equals negative 58. So I will eliminate my x by multiplying this by 2. This is now negative 14x plus 30z equals 58, and this equation 14x minus 30z, just copy it, negative 58, and we add it together. This is x cancel out, z cancel out, so we have a dependent equation system here. So that means it doesn't really work the same way as what we did in two variables. So what shall we do then is we need to tweak a little bit here. Okay, remembering our, what is our x? Our x is negative 2, y is 0, and z is 1. So let's go back to our target solution, which is x is negative 2, y is 0, and z is 1. Now what I'm going to do is I will tweak a little bit, like this is my x, this is my y, this is my z. Okay, so I will not change anything from equation 1 and 2. I will change only a little bit of equation 3. So this is what I'm going to do now. Just copy equation 1 and 2. Okay, 12 x. And then the equation 3, this is where my change will go. So what I'm going to do here, plus 3z, I'm going to add z here. Okay, change a little bit. And since I add z here, I will add z as well on the right hand side. But since z is equal to 1, I will just simply add 1. Okay, so now my equation becomes 5x minus 6y plus 4z equals 2. And then I will copy the rest of the equation, which is negative 3x, 5y. And the first equation, 4x minus 2y minus 4z plus negative 12. So this is my equation 1, equation 2, and equation 3. Let us now check if this really works. So I will pair my equation 1 and 3. So pair equation 1 and 3 to eliminate the y. Okay, so what I'm going to do here is I'll multiply this by negative 3 to equation 1. So this now becomes negative 12x plus 6y. This is positive 12z, and that's positive 36. And then my equation 3, just copy it. 5x minus 6y plus 4z equals 2. Then let's add them. Y is now eliminated. So we have negative 7x, and this is 16 plus 16z equals 38. So this is now my equation number 4. I move to equation 1 and equation 2 to eliminate my y again. Okay, so here I will multiply this by, okay, I'll multiply this by 5 and multiply 2 to equation 2. So this is gonna be 20x minus 10y minus 20z equals negative 60. And here, for equation number 2, multiplied by 2, get negative 6x plus 10y minus 10z equals 2. So our equation 1 and 2, well, we already multiplied 2 here. Okay, this one we get 14x, y is eliminated, and this is negative 30, z is equal to 50, negative 58. This is our equation number 5. So we join our equation 4 and 5 together because they are equation in 2 variables already of x and z. So this is equation 4 and equation 5, them together. So what I'm going to do is I will multiply this by 2 so that my x will cancel out and I can solve my z. So 2 times negative 7, that's negative 14x plus 32z equals 60. And then for equation number 5, that's 14x minus 30z equals negative 58. Our x is eliminated, positive 2z, and this is equal to 2. That means our z is equal to 1. Okay, so we have now solved our z. And for our y, we can use any of this equation. I will use equation number 4. So I'll change my z to 1. 7x plus 16, or z is 1, plus 30. So negative 7x, well, that's 16. I'll move this to the right side. That's 30 minus 16. It's negative 7x. 30 minus 16, that gives me 14. And divide negative 7 both sides. That gives me x equals negative 2 for the x. And to solve for y, we substitute it to any of the equation. Equation 1, equation 2, or equation 3. Now it's already here. So I will select equation 1 instead. So I have 4 times my x is negative 2, then minus 2y, minus 4 times my z is 1, and plus negative 12. Okay, so this is equal to negative 8 minus 2y minus 4 equals negative 12. Put this together, that's negative 12. So that's negative 2y minus 12 equals negative 12. If you put this here, it will become positive 12. And negative 2y equals 0. That means our y is equal to 0. So the solution, our x is negative 2, y is 0, and z is 1, which is exactly what we want from the start. Okay, so that's it. If you want to construct system of equations of 3 variables, then you have to tweak a little bit of one of the equations so that it won't be, so that you won't have that chance of having a dependent system.